Okay, another question about the flow rates. What are the typical coolant flow rate per cold plate? Yeah, in general, how to size the system? Maybe what flow rate should you assume? Because if you are thinking about buying coolant distribution units, you need to take into account the flow rate which that coolant distribution can provide, and also a couple of other items. But let's start from the flow rates. Well, there were different requirements, and they were going like this. So, and we have ongoing discussion in the industry what the perfect flow rate should be. But let's start from the, let's say, current one. Previously, we are using in general, the understanding was to have 1 liter per minute per kilowatt. Then we went slightly up to 1.2 liter per minute per kilowatt, and that was the understanding for the most of the time. There was a moment with the beginning of the year that NVIDIA was announcing that they just need less than 1 liter per minute, 0.9 or something like that for those racks. But right now, the general understanding when we are thinking about the coolant distribution units and the flow rate which you would assume, thinking about the current racks and about the future, is 1.5 liter per minute per kilowatt. So if you are having the coolant distribution units, which can, for example, deliver approximately, I don't know, 1,200 liters per minute, divided by 1.5 liter per minute, and that will give you the approximate number of megawatts which that coolant distribution unit can provide. And please remember, always ask, I cannot stress that enough, whether the flow rate provided by the supplier of the coolant distribution unit is assuming that you have N+1 redundancy. If the CDU has 2 pumps, is that flow rate for both pumps operating at the same moment? Or if that's flow rate working, which was assumed only for 1 pump operating, so having N+1 redundancy on the coolant distribution units. Because different vendors provide different numbers. We assumed that we need to provide always flow rates with the assuming N+1 redundancy for the CDU. So 1.5 liter per minute, assuming that all the CDUs have N+1 redundancy.